Hello, hello, it's me, Ugo, and this is String of Missing Elements. It is not a leak code problem, um, but this is the umpire method for it. So the problem distinction, the description is, it just says that we are given a list of distinct integers from 0 to a value max, and we have to write a function to produce a string that describes the range of numbers missing from the list. The items in the result should be sorted in ascending order and separated by commas when gaps only span one number. So if there's single numbers that are missing and not ranges of numbers missing, we're just going to put that number by themselves in their own little column or comma. And then if there is a range of numbers, we're going to get the starting number from that range and the ending number for that range, and we're going to put them separated by a hyphen and then the comma afterwards. So, I think it's hyphen. I'm pretty sure that's the name of the symbol. But one thing it's not mentioning here is that a few things. The input list is sorted, and yeah, I think that's the main thing to worry about. They're distinct integers from 0 to max value. They're all sorted. So we know we have a range of numbers from 0 to whatever the max value input it is, and we're given a list of integers that are in that range of 0 to max value, both being inclusive. And that list of integers will just be used to show what elements we currently have, and we're going to base our result string, where we find the ranges of elements that are missing, off of it. So this problem isn't really that crazy. I mean, at first it looks a little weird because it's like, okay, how do you do this? You know, how do you get the range of numbers and then put it in a string that's just expanding over time? So originally my first approach was just, we're going to iterate through we're going to create a list of numbers that is the valid list, so the total list, which would be the elements that we currently have, or it would just be made up of the range of 0 to the max value plus 1. And then we would use that to check if, when we're iterating through values, if the number we're currently on in values is not equal to the number we're supposed to be in for that range. Actually, wait, that might have been quicker. I don't know. I didn't go with that approach. I'm a little tired right now, but and I did this a few hours ago, so I don't quite remember why I didn't do that. I'm pretty sure it's probably not actually effective and misses a lot of information, probably. Or at least it would be very messy and all over the place. You'd have to have conditions for the edge cases where they're outside. So like in this case, you have 76 to 1000. How do you handle that? Yeah. So I didn't go with that approach. Instead, the final approach I came up with was we would first create a set. Actually, I don't like, that was my first implementation, but my second implementation. Late? Why does it say late? Oh, 2021. What? That's weird. I don't think that's normal. Anyways, whatever. So here's the final solution I got with. I created a set from the number or the array that we were given. So the elements that were provided at the start, the list of elements, I created a set from that. This is an O of n operation to do. And this is useful because later on we're going to be iterating through the range of elements that we're supposed to have, and we're going to be checking if I is inside of it. So having a set would make the lookups O of 1 or O of a log n at worst, I'm pretty sure, or O of n log n, one of the two. Let me check. Worst case lookup sets. O of n. Damn. I didn't know if it was O n. I didn't know it was O of n. I thought it was O of log n. But yeah. So worst case, it's as bad as a list, but best case, it's going to be O of 1, or constant time. And we're repeating this all the way up, or max value number of times. So it's important to have that, so then we don't have an O of n squared behavior over here. So if it's not inside of the set of elements that we were provided by at the start, we're just going to simply mark our starting location. So that's going to be the start of the range of elements that are missing. And then we're going to move forward. And we're going to move forward as much as we can until we find an element that is in the set. So we start at I. I is not in it. That's the start of the range that's possible. And then we're just going to keep moving right while I is still in the range possible. So if it ever exceeds max value, then we're done. Or well, that's like the base case. So just making sure that we're within the valid range. And if we are within the valid range, we're just going to make sure that the I is still not in the set. Once we find our first element that is in the set, or we exceed the range, that's when we break out of this looping behavior. So this might seem bad, but since we're using I for a while loop too, this actually continues keeping the O of n behavior, because rather than having to like go back to where we started, we're actually moving forward through the range, and we're not going to go back anymore because we've already dealt with that range before, so we don't have to worry about it anymore. And after we're done doing that, we're just going to get end I minus 1. And the reason we're subtracting it by 1 is because this is the first element that we find that is in the set. So because I is incrementing, and it's like always incrementing up to max value, once we find it at this in the set, that means the last value of the range of missing values was the one before it. So we just subtract it by 1. And this works in cases where there's only one number that's missing, because this while loop will always be triggered to be true at the start. So no matter what, this is going to at least run once, because I has to be less than max value to get to this point, or this if statement, which will get you to the start statement. So I is less than max value. This is going to be true always when we're here for the first time. And then because we already checked if I is not in the array set, then this condition is always going to be true once we get to it, because it had to be true right here to get to it. So the first iteration will always occur. So we'll always have I plus equals to 1. So we're going to increment it once. And if it fails to satisfy that condition after moving forward once, like the condition of what being before or within the range possible and not in the set, if those conditions fail, then it's fine, because the incremented value will be decremented in the following statement, and we'll handle that case with an if-else statement. Nice and simple. Actually, I probably could have used a ternary operator here to make it even cleaner. Like yeah, I think that I like that more. So I could have just done ranges.append f string. Could I? Could I do? No. I'm not doing that. I don't even know if it's possible to do that. I kind of wanted to do a ternary operator within the f string, but I'll avoid that. But I'll definitely look into it. So if start is less than end, then we're gonna want to do the range, because if the start and the end values are not the same, that means, well, start will always be less than end because we're only going to be increasing or at the same point because of this statement. So we can guarantee that we will only ever be less than or equal to, start will only be less than or equal to end. It will never be greater than it. So we only have to worry about those two conditions. So if the start is less than end, that means that there was more than one missing element, and that means we have a range of elements that are missing. So that's when we do the little range for the f string. And then else, if that condition is not true, that means that start is equal to end. And in that case, we only have one missing element, which would just be the start or end, whichever you prefer. It doesn't matter at this point. And that's the equivalent of this. So that's essentially what I was just doing here. I just like it more in the ternary operators. I like ternary operators. But yeah, and then we're gonna increment after that, so we move forward once. This just makes sure that we're not constantly stuck in that one, that we're not stuck in an infinite loop. The reason we don't put this into an else statement is because if we don't increment it after appending the missing element, we're just gonna stay, or actually, maybe. No, it's better if we don't increment. It's better if we increment in both cases, because we know for a fact that the I value that we were at is not missing, because that's the thing that caused it to break, or it's just great. It's just outside of the range. So either case, it's always going to break out no matter what. If the conditions are, well, it'll break out if we've gone past the values, because this will just increase it more. It's not like it's going to affect anything with the ranges. And because if this condition was satisfied, so if we're still within the range, that means that the only thing that broke the condition was that I was in the set. And if I is in the set, that means we've already checked if it's not in the set, so we don't have to worry about this condition anymore with that I. So we can just skip over it, because that's the one that broke this condition here. So that's an unintended trick. I'm glad my code does that, but I feel like maybe I should have made that clearer. But I'm not really sure how I mean, I guess I could. It'll just be slower by one iteration. Should I? I mean, I guess it's the same. In both cases will work, I'm pretty sure. The only thing that would happen differently is that we would just have to do an extra check right here where it will always be true, which is unnecessary, which is why I think the else would probably be better just left alone. And after that, oh right, the big thing about this this approach is that we're appending strings to a list that contains strings of range, that will contain strings of ranges or missing elements. So the reason we're not just appending the value to the return value at the start is because using the return value would actually be very inefficient. So although, let me show you in Python Tutor. So although the steps required to do both of them are the same, so in this case we're appending it, and then in this case we are in this case we're appending it, in this case we're concatenating it. So concatenating would be the one that's bad. Sorry if I was saying append. If we concatenate the string to the return value, that's actually worse. And although the step count says otherwise, the thing that's happening that's different here is actually a time complexity issue. Because under the hood, what's happening here is O of n time. Or at least the length of the string is the thing that's happening here. So it's like the time complexity is the length of the string. And that's not ideal. That's far from ideal, actually. While append is O of 1 time, I'm pretty sure, if I'm not mistaken. Append time complexity Python. I'm pretty sure it's constant time. constant time. So we have a constant time operation versus a O of n time operation, or O of m. I don't know. I guess you could create separate variables for the size of the string versus the inputs, so to not conflate them. But yeah, it's just the string size in time complexity that gets added, and because this is happening every time we have a range that is not in, or that is missing, the more numbers, the more the num an increase in missing elements that are not connected in a range cause this to be worse. And this also gets worse as you go further into the string. So at the start it might not be too bad, but once you start getting into the, like, if you get like a very long string and a bunch of different distinct thing or strings to or missing elements to append to it, this would be worse than this because it's just constant time, and this is happening inside of the loop while this isn't while this is only appending, so it's constant time, so it's not a problem. And the reason we do this approach, or can make up for this approach, is that we can use join later on to join the different elements within the ranges. So remember, if we look earlier, the result should be stored in ascending order, which is just going to happen naturally as we append things while iterating forward through a sorted list. But other than that, the condition is that it has to be separated by commas. I don't like that it says this here, because in the actual result, it requires that you turn it in with a space after the comma. But we need to have them separated by the comma. So this is actually even better than the other one, because the other one would have a lot of formatting to deal with. While this one, because everything is separated in a list, you can quickly just join the list together into one string with that comma separator at the end. But in the actual string implementation, what you would have to do is you would have to concatenate it with a comma and a space at each concatenation, and then at the end you would have to right strip the space, and then after that right strip the comma. So then you can get rid of that trailing comma and space. So it's like, time complexity wise, this is a lot better than the string one. And then also just formatting and like the simplicity of it is a lot simpler as a list. So yeah, that's the reason why I chose this implementation. Now, if you notice, I had 3 Python tutor open rather than 2. That is because later on I decided to just ask an AI, hey, is there a way to do this better, or am I just off the track? Is this like far from ideal? And they were like, no, that's pretty good, but they offered another solution, and I don't fully understand it. I haven't gone into this level of Python before, but I thought it was interesting and wanted to share it. So what they said they did was used a generator function. So I'm pretty sure this is the generator function. And it uses this keyword used called yield. That's kind of like return. And we're calling that function in a for loop. So we're kind of like separating the logic between the range, like the string handling for ranges, and the actual like logic behind finding the range of missing elements. So this is like the string formatting part, and then this is the actual logic for finding the ranges, and they're separated into their own functions too. All right, I still had it called domain. I didn't know what better name to call it. But yeah, like this solution, according to the AI, this solution isn't much better in time complexity, really. I mean, if we look at the steps too, it's the same thing basically. 278 for a range of 101 with 5 elements total in the list. Not the craziest thing. It's literally the same amount of steps, or well, it's one less than this one because I created the list right here. But they're basically all the same. So but apparently generator functions are used to like reduce memory usage, so and they improve performance when repeatedly calling them. But then I like digged a little deeper into it by asking just more questions about what was happening here, and it said that for our application it wasn't really helping that much in memory because we're still storing everything into the range anyway, or the ranges anyway right here to join later on. So it's not like it's gonna make that much of an impact, but I thought that was pretty cool and like a shout for another solution, you know. And I mean, if we look at the end, let's see, what did we get printed out right there? Let me just make sure that everyone got the same code at the end. 1 to 3, 5 to 9, 11, 13 to 99, and 101. And that seems to be the case for everything. Yep. So that was missing element step 3. I don't know why it's called step 3, but yeah, there's a string of missing elements problem. I liked it. I thought it would be a bit harder when I first read it, but I really like that it's like it feels like it should be an O of n squared solution, but there are ways to make it into an O of n solution pretty easily if you just know like the basic stuff that we learned in the previous courses. So I liked it because of that. I thought it was cool. My final solution with the list was what was it? I think it was O of nm, where m would be the number or the length of the string that is missing or represents the missing stuff, and then n is just the list provided or the range provided. I forget which one would be the determiner for that. As opposed to the string version. So the string version would actually be O of nm squared, which is why even if it says that it's 248 steps, under the hood, this part would just be slower. It would just be slower. So I really liked it. It's one of those cases where like the number of steps can't really be shown in Python Tutor, but the difference between them is there, and it's cool. It's cool to go over problems like this. But yeah, that's all.